Hi everyone, welcome back to MarWorld Around the World. This is going to be session 4 on big data, AI, and the ocean. And just a quick reminder to anybody who's watching live on YouTube, please feel free to ask your questions, leave your comments. We will try to get to them and we will try to post them to our panel members. So this session is going to be on artificial intelligence and the way big data are transforming how we understand and protect the ocean. With contributions from researchers and practitioners working in Canada and Europe, this session demonstrates how AI bridges scientific research, operational management, and real-world conservation challenges.
Reducing bycatch and improving fishing gear selectivity through real-time data analysis and predictive modeling enable fishers to avoid non-target species and vulnerable habitats.
Detecting marine megafauna, such as whales and sharks, from satellite imagery and underwater video, with implications for conservation, tourism, and ship strike prevention.
Automating coral reef monitoring using AI and power analysis of underwater photos to assess coral health, stature, bleaching levels, and recovery trends, enabling faster, scalable, and objective assessments. So our speakers, we are really glad to have them. They are free today, and we will have Emily Charitizer, CEO of Well Seekers, now in Canada.
We have Marco Milanesio, a research engineer at the Université Côte d'Azur.
And Robin Fayetaz, a researcher at Ifremer in France. Thank you for joining us.
Thank you.
Thanks for having us.
So I think we were thinking to start and jump in directly with you, Robin, and to give you more, if you can give us more insight about what you're doing.
Hello everyone, so my name is Robert Fayetaz. I'm a researcher at Ifremer Lorient in France. The lab is dedicated to the study of fishing gears in particular and how we can improve the fishing gear to make them more selective and to reduce their impact on the marine habitat. So I don't know if I can already share the video. I just wanted to show you the main project that we are working on. The project is called Game of Troll. And the idea here is to see how we can combine the use of AI. I'm sorry, I'm going to launch it. How we can combine the use of AI to make the fishing gear becoming active, in that we would see in real time what species are entering the troll. We would detect them and determine whether the species are to be targeted or untargeted. If they are not targeted or threatened, we may just activate a hatch that would exclude the species from the troll, and in that we would only bring on board the species that would actually be kept unsold for human consumption. So the idea here really is to see how we can automatize this process that is not human feasible, because in real time there will be too many individuals, too many fish species. And here the AI is really providing a very good tool or a mean to achieve something that we would not be able to achieve without that. We still have plenty of limitation with the image quality, the number of individuals, the species detection that needs to be reliable, because we want to be sure that we do catch and we do identify the species that we are interested in. But this is really one of the first prototype that exists around the world of an active troll that is fully automated and can already be controlled by AI. I would be glad to discuss the pros and cons afterward. And the other main application that we have with AI that we would not be able to handle without is for the bycatch of dolphins and other cetacean or protected species, where we have tons, like it's hundreds of thousands of hours of videos of electronic monitoring in which we want to detect the few hundred of bycatch events that have been observed. And with that, we deploy AI artificial to detect the bycatch of these sensitive species and to have a more thorough monitoring of these events.
Okay, thank you, Robin. I was just also wondering if I could just ask a quick question, and that how has AI changed the way that you work with big data? I mean, what new opportunities has it opened up, or how were you working before?
I think the AI is really providing, I mean, in my case, of course, it's really providing a different way to deal with the data, in that So my main focus actually before the AI was to study the behavior of the different species. So with that, I use imagery, I use AI to track the individual and to facilitate my work. But it's the AI really changed the fact that going from very fine scale things like processes where we would just be a human that looked at the video and process the data, a few hundred of videos or a few thousand of videos maybe, but it's extremely time consuming. And so it's not feasible to handle a huge amount of data. So monitoring all the vessels that are fishing in the Bay of Biscay is not feasible just by human. That's impossible. Yet with AI, that becomes possible. However, we have to accept that we have an error rate that comes with this new data that we have. So we deal with a much larger amount of data, although we do have to accept, to tolerate that there will be some error. So we are not going to something very fine scale, very, very exact, but we go to something that is more like around big trends where we have some errors, but if there is a strong trend with this big data and AI approach, we are able to detect this larger trend at scales that we would not have been able to achieve before.
Okay, thank you.
Yeah, I think, well, you talk about bycatch and you talk about like the cetacean, for example, so can jump in with Emily now, and if you can explain a little bit how you're using it also to detect the marine megafauna.
Yeah, thank you so much. So absolutely, and I think Robin's presentation really leads really well into what we're doing as well. So I'm the CEO of Whale Seeker. We're a company that works in Quebec. Well, we're based in Quebec, but we work all over the world with images all over the world. We use AI to detect marine meso and megafauna from aerial images, so images taken from the sky, so from drones, from aircraft, and also from satellites. And the main solution that we have is called Mobius. It's a human in the loop AI solution. And on the right here, you can see an aerial image of some narwhals in the Canadian Arctic, annotated this way. As Robin mentioned, going through images is a very tedious job. It's a bigger job than humans alone can do in order to give decision makers the data they need to make timely and meaningful decisions. And he also mentioned error rate, and of course AI is not going to be perfect, but what we're always aiming for is just better than what we have right now. And what we have right now are a lot of different observers that are counting, in our case, marine meso and megafauna from aerial images. In Robin's case, fish and other marine animals. But there's an and intra observer bias as well. So even if humans are doing it, it's not going to be perfect there too. And that is also very time consuming to quantify. And so I just wanted to give a little example of some of the images that we're looking for. As you can see here, some of these narwhals are at the surface. They're very easy to detect. Some people say, oh, well, it's like Free Willy, a whale is a whale is a whale. How hard can it be? But there are some whales that are deeper down. There's a very complex bottom of the ocean there as well. So it gets into the judgment call area very soon. And that's also what we're trying to standardize. So as you can see here, there's another image of the Canadian Arctic with annotated narwhals. And also, I just want to give you an idea of the complexity that we have too of dealing with real world data. So all the environmental variables, different weather, different animals, sun glare, waves. In this image, there's a lot of ice, and you can see one lone whale annotated in the top here. And so here's another example. So we're called Whale Seeker, but we don't just find whales. As I mentioned, it's marine meso and megafauna. And in this image, there's one single seal, and the seal is on the ice. And I know that we're pressed for time, so I'll cut right to the chase because you really don't even have a chance of finding it. And it's right here. It's this It's this shape that's sitting on the ice right here. So definitely a time-consuming task with a lot of error built in. If it's humans doing it, if it's AI, it's a big enough tool that it can deal with vast amounts of data, millions and billions of different variables, in order for us to maybe really make the task much faster. So I just want to give a couple examples of work that we're doing with regulators. So everything that we've done has been co-published and developed with regulators to make sure that our AI solutions are at that level. And so here we published a paper with Fisheries and Oceans Canada, looking at an aerial data set that they annotated all by hand, and we compared it to our AI to see, is it actually as accurate as the human experts? Is there more standardization? We found that yes, there is. We also are working with Transport Canada in order to detect the critically endangered North Atlantic right whale in real time. And because we are an AI company, but I'm a community ecologist. My husband, the co-founder, is a marine biologist, and we also have oceanographers and other biologists on staff. We really make sure that we have the technical expertise, but also the domain expertise, because just a technical tool sometimes cannot give the answers that the users are needing to answer their scientific question or their applied question. And a good example of this is we detected 112% more individual whales in our very first year of working with Transport Canada than just the pure tech company that they were working with before. Without, tech without context is not very useful. We're also working with satellite images. And I just wanted to also give an example that it's multi-sectors all working together, that we're really breaking down silos, that AI is a tool that academia can use, that conservation can use, regulators can use, private industry can use, and that it's really an opportunity for everyone to come together and move the dial forward in terms of ocean data that's accessible. So thanks so much. Happy to chat with everyone.
Okay, cool. Thank you for sharing that, Emily. I think before we kind of move to a more general conversation, I was wondering if we could just bring Marco in and kind of like, if you could explain how you're integrating AI and big data into your work.
Yes, of course. Thank you very much for having me. I'm Marco Milanesio. I'm a research engineer at the University of Côte d'Azur, and I work in collaboration with teams of biology at IRCAM to actually assess coral health via imagery and image analysis. You have an example of an image that we are currently studying, and you can see from images like this, which are taken from scuba divers across different sites in Indonesia. For example, this comes from Indonesia, and there is a number of features, a number of characteristics of this coral that can give insights on the health status of the coral itself. And we are integrating different AI technologies and different AI algorithms to actually try to automatize this task, because as Emily pointed out, I mean, it's really difficult to do it by hand for two reasons. One is time consuming, and the level of detail is enormous and gigantic. And second, depending on different experts may have different opinion on what they are actually looking at. And so there is the need, and this is what we are working on, of actually developing some sort of unified protocol to assess and define what are these features on top of a colony and how to bind them into a notion of health status of a given colony. And of course, the challenges here are multiple. Okay, there is the annotation part. There is also the heterogeneity of the data, because we don't have a standardized way of taking pictures, depending on the distance, the size, the luminosity, the water condition, the light condition, and so on and so forth. So we are trying to actually to merge all of this variability into one single framework to actually assess this thing. And we can define basically two different levels of AI approaches when working with images like that. There is, let's say, the easy part, which is, let's say, the identification of a colony. For example, this colony here that you see in the image is a Fossilopora, and this thing can be easily automated. But when we are dealing with, let's say, define and find what are all the algae which are actually on top left or on the far right of the coral, as well as all the different microorganisms that are inside this picture that you cannot see it by naked eye. And also you can find some sort of pink spot, which are pigmentation, which is a stress response due to heat. I mean, there are different difficult tasks that AI can help overcome, provided that we are able to define clearly what is the correct protocol for assessing and defining this feature. And so my job basically is twofold. On one hand, I'm working on the implementation and on the development and deployment of this algorithm. And the second hand is the definition of a global and more general purpose database to be used for further investigation on this sort of problems and pictures.
Perfect, thanks a lot. So I guess we can open to more general question and to have your different view on it. Again, for the one who are watching online, do not hesitate to spread a question if you have, but I guess you talk a lot about decision makers and how we can help towards this, but AI is a big subject also. So how do you feel, or what is the main, I don't know, challenge or risk you see with that when you go to decision makers? Or to conservation also in general. I know it's huge, so I don't know who wants to start. If you want to go, Emily.
I can start, and I'll pick up on something that they both said, but it's not perfect. And so what's tricky with AI, I feel, is that decision makers either don't have any confidence in AI at all because it's such a black box, they don't trust it, or they want to trust it completely and they want to completely automate the task. And really, we should be thinking of AI as a tool. So moving from sort of a manual screwdriver to an electric screwdriver, so we can do the task over and over again to a high quality standard. People can do more with less. But I would say that's one of the main problems that we have, which is why we looked at the data that the decision makers are using to base their decisions on right now, and we're trying to reframe away from, what are the statistical scores, because in real world, there is no perfect, there is no absolute answer. So how do we just do better than what we have right now and give decision makers higher quality, faster access to data?
And Robin, if you want to follow up, maybe,
or to answer all Emily's questions.
No, so I'm 100% in line with what Emily just said. It's all about this error, and I think so. There are different problematic that each of us may be facing in relation to the stakeholders and the managers. It's so in the case of the fisheries, if I think about the issue that we have with the bycatch, we also have the fact that the data collection rely on the actual fishers. Because they are the ones that go at sea and that do activate, the camera should be on all the time, but it's still like the data collection relies on the willingness of the users, and so we also need these people within the chain to collect the data and to rely or to know why we collect it and precisely what we are going to do with the AI. And I think so the other maybe not the issue, but the big thing with AI is that most of the people think it's a magical tool. I mean, you just go on ChatGPT and type something and say, "Wow, I'm amazed," and myself too. I mean, I was quite against it. I started using it this year, to be honest, and for some use, it's extremely powerful, and I think that's exactly the message. It's for some use, it's extremely powerful. Just like Emily said, you want something that the AI will never get tired, basically. So you're always going to have the same error rate and the same mistakes that will be done in the same situation. But that also means that the AI is always going to be correct in all the other situations when it's not wrong. So in a way, you really get something that is more standardized, but the thinking that we have that it's a bit magical makes it a bit dangerous because we tend to overlook the bias that are inherent to the training and to the data that have been used to train the model that will be propagated within the detection and the inference. So I think that's really it's like any tool. It's exactly like Emily said. I'm sorry I'm repeating, but it's really just a tool, and it's the way we use it that make it worse or can even be dangerous if misused.
Yeah, this is why, if I can jump in, this is why I mean, it can be useful, and this is something that we are doing. It's something like taking the AI and put it in the loop, let's say, for some sort of evaluating what is the result, because it's one of the problem is explainability. So why they have a given result, and we confronted the output of, let's say, our machines against expert, and see how it compares with respect to an expert. And this can give some sort of further, I wouldn't say fully convinced, but actually help in the decision process to say, okay, it aligns somewhere, it aligns not otherwhere. So, but there is a middle ground to be found between the experts, which is, I mean, costly and unfeasible to work with, and AI, which can be used as a black box, but mainly, I totally agree, it's just a tool. And so we need to be able to explain in some way and make this explanation as clear as possible. But it depends on the task, of course.
Okay, thank you. So one of the things we think about at MarWorld and also thinking about with UNOC is sustainability and sustainable development. And obviously I was wondering if you had any kind of like perspectives on the relationship between AI and the sustainability of this infrastructure, about maybe its energy usage, or within kind of like more broadly thinking about the way that, say, with data servers and the kind of like the environmental kind of like implications of expanding and integrating these sorts of like technologies and infrastructures into our work.
I mean, sustainability can be declined in many different domains, but actually, for example, one of the projects that we are following regarding corals involves local communities in the islands where we actually work, and the goal is actually to put the people there and make the people there actually be part of the project. And this will lead to tourism and lead to further activities that are developed alongside this specific project. And this is one way of dealing with this. Of course, sustainability from an energetic point of view, I mean, it doesn't scale that much at the moment. I mean, you have to compromise efficiency and performances against costs, and this is, I mean, we are not there yet in our project, for example.
I'd love to jump in just 1 second to also highlight that there's different kinds of AI. So the AI that is really energy intensive is generative AI, where we're taking a lot of data and we're creating something new like ChatGPT or DALL-E. And it sounds like the types of AI that the three of our projects are using are analytical AI. And so we did an energy analysis looking at how much energy it takes to manually annotate a certain data set versus the energy that it takes to train our algorithms and then annotate the images through AI. And it's 98% less energy intensive to use AI. So this is another one of those situations where AI just sort of gets lumped into a lot of stereotypes. So that's talking about energy sustainability. And the other thing that I noticed with the three of our projects is that we're all involving the local stakeholders. We're using images that are normal imagery. We're not using very fancy, expensive images as well. And so all of this really brings down the entry bar and democratizes access to AI and to ocean data. And we know that ocean data is expensive to get, it's hard to get. And it's one of the reasons why managing the oceans is so difficult, is because we're lacking that data. And I think the three different examples that you have in front of you here today, they're doing things that are using AI in a more energetically smart way. And so we're getting more data, better data with actually less energy usage. And we're also using data that is not out of reach to coastal communities and users.
Thank you. And Robin, if you wanted to add a few comments.
I just wanted to add something about the energy efficiency, because in the Game of Troll, what we have is an embedded AI. So it's an underwater housing in which we have the camera, we have the GPU, and we do all the processing in situ, in real time, underwater. And we are limited with time, so we are limited with battery, and we have actually made, I mean, I say we, but it's not me, it's the people that do the code. But we've made a big effort to actually make the thing very I'm sorry, I'm losing the word, very efficient in energy. And basically like the GPU that we are using, which are all these small GPUs that are made for embedded device, and we use them to 35 to 50% of the maximal consumption. So, but we still get, I mean, we could go like we could do 25 FPS, so real time 25 FPS detection of the species in real time underwater, but we would consume more, and we don't need to that level of accuracy, I mean, of temporal resolution in your data. So what we do is actually to determine the frame rate or the sampling rate that we need in the data to process. So we are efficient in the data that we use, in the energy that we consume to run the AI, and so we can really make a lot of optimization to make it cost efficient and energetically efficient. And just the last thing I wanted to say, it was not exactly the point of your question, but about sustainability, but maybe it's no, actually it applies to all of the different projects because it's about the management and everything. But the AI as tools can really help in making our marine usage more sustainable in general, because we can have a more thorough understanding, a more global overview of all the different processes and at different resolution, different scales. And so I think, although it comes with some additional cost, because we do collect new data and we do not use the same energy to run the AI, we do get a new overview, a new vision of processes that we could not, that eventually may lead to more sustainable use of the marine resources.
Okay, thank you. I guess like we're coming towards the end of the session, so I wonder if we could just maybe have 30 seconds just for kind of like a takeaway from each of the speakers about AI and big data. I mean, maybe beginning with Marco again.
Okay, takeaway. I mean, it depends on the task, as we saw in this project. I mean, of course, the more data, the better, but the more data is more error prone. So it's a fine and difficult trade-off to find, and this is one of the things that we have to be more careful about in applying AI.
Okay, thank you. And then I guess Emily?
Yeah, I would like the takeaway to be that there are solutions now that are ready for scaling by governments and by regulators, and that the examples of AI that we have here today have all been tested. They're all very scientifically rigorous, and they're not just research projects. They're tools that can be scaled more widely in order to integrate into different policy making, different insurance schemes, different conservation efforts, and that it's a tool that people should be thinking critically about, but shouldn't be afraid to use and scale.
Thank you. And then Raban.
Yeah, my conclusion was about keeping the critical thinking about the AI and remaining nuanced in that the human brain is magical, but AI is just a tool. So don't forget that when you use it, it can be very useful, but don't forget that the brain is more powerful.
Cool. Thank you so much. I think, something really important perhaps we can bring back, but it's through also this session is to align again with SDGs and and that you showed that, of course, it's linked to SDGs 14, life underwater, but like to subcategory, like sustainable fisheries, bycatch reduction, that you have scientific research and marine technology transfer, but also then to SDGs 9, which is innovation and infrastructure. As you said, it's a tool, and that if we use it wisely, it can be super, super powerful. So, well, thanks again to have been with us, also online if you were with us. Of course, for future moment of the dance. Thank you guys again.